I'm going to do a couple of examples of those. Sentence went in the wrong direction. I'm not going to do the integration because I figure that's easy. Well, that's easy once you decompose the fraction, or it's not what I want to focus on for this lecture, or this little baby lecture. So, examples. Let's say I have x over x plus 4 times x minus 1. The degree of the top is 1, the degree of the bottom is 2. So we have the condition that the bottom is the bottom is bigger degree than the top. Both of these factors are linear, so I'll put a single constant on top of both, a over x plus 4 and b over x minus 1. And if I bring those together as a fraction with the common denominator of x plus 4 times x minus 1, I would have a times x minus 1 on top plus b times x plus 4. And I really only want to concentrate on the top, so I'm going to usually skip this particular writing out. What I'm going to go straight to is the next step where I say, okay, the numerator on the left is x, the numerator on the right would be a times x minus 1 plus b times x plus 4. This has got to be true for all x's. In particular, I want to look at x equal 1, because that will give me the equation 1 is equal to, oop, that's gone, that's 0. Put a 1 in here, I get 5b, which means my b has to equal 1/5. If I let x equal -4, then I have -4 is equal to, well, -4 minus 1, I get a -5a plus 0. That's gone. So this means my a is equal to 4/5. So my fraction of x over x plus 4 times x minus 1 can be rewritten as a, which is 4/5, over x plus 4, and b, 1/5, over x minus 1. So that's the decomposed fraction. Let's try another one. Let's say I have 2x plus 3 over x plus 1, quantity squared. Now I have two linear factors, but they're the same thing. So I need to look at what happens when it's only one of the x plus 1s and when there's two of the x plus 1s. So I'll set it up with an a over x plus 1 and a b over x plus 1 squared. So the numerator, when I bring them back together, on the left I'll have 2x plus 3, and on the right a still needs an x plus 1, but b needs nothing. My choices for x's. Let's choose x equals -1. So I have 3 plus -2 is a negative. No, it's not. It's a 3. No, it's not, Megan. It's a 1. We'll get it eventually. The a goes away, so then I'm left with a b. So that means b equals 1. I need another number. Let's go for 0. If x equals 0, I'll have a 3 on the left. That's a 0. I have an a, and the b doesn't go away. B is equal to 1, so I subtract that over, and I'll get a equals 2. So breaking down this fraction, I will have 2 over x plus 1 plus 1 over x plus 1 squared. Let's try another one as I look in my notes on the other side. How about if we had x plus 4 over x squared plus 2x plus 5. Now I look at this, and I don't think that's factorable. So I'm going to look at the discriminant. That's that part under the square root in the quadratic formula. So the discriminant is b squared minus 4ac, which in this case is 4 minus 20. That's negative, which means this is not factorable. which means I can't use partial fraction decomposition. There's nothing to decompose. It's down to its bare minimum. So I will have to, if I had to integrate this, I would have to find another way of integrating it besides breaking it down using partial fractions. So this is not the one. Okay. Let me try one more. Let's say we have x squared plus 2x minus 4 over x cubed minus 4x. Now looking at this, I can factor this as x times x squared minus 4, or x times x minus 2, x plus 2. So when I break this down, I'll have an a over x plus a b over x minus 2 plus a c over x plus 2. Bringing together like common denominators, let me see if I can scooch this over here, I would have x squared plus 2x minus 4 is equal to a. Well, a is missing x minus 2 times x plus 2. My b is missing an x and an x plus 2. Can she fit it on the page? And my c is missing an x times x minus 2. Yes, she did. So now let's figure out what a, b, and c are. My first choice for x will be x equals 0. If x equals 0, on the left I have a negative 4. And on the right, this I'll have to come back to. That's a 0, that's a 0. So the b and c are gone. But if I stick a 0 in here, I'll have negative 2 times a positive 2, so I get negative 4a. So a equals 1. Now my next choice will be x equals 2, because that'll make that one 0. So my a term is 0, my c term is 0. I'm left with the b term. So b times 2 times 4, actually let's do this side first. I get 4 plus 4. I have 4 is equal to, my b is going to be 4 times 8b, which means b is equal to 1/2. Oops, give myself some more room, spill my soda. One last one, let x equal negative 2. On the left, let's see, I've got a positive 2, 4, negative 4, negative 4. I have a negative 4 on the left. Negative 2, so the a is gone, the b is gone, and the c I have negative 4 times negative 2, which is 8c, which means my c is equal to negative 1/2. So breaking down this fraction, I would have 1 over x plus 1/2 x minus 2 minus 1/2 over x plus 2. So that's how I break down that fraction. So those are 3 examples, 1 non-example. I should do one with x squared, but I think I'll stop at this one for today. Enjoy.